Hello, I am Judith Brown, a mathematics lecturer at Brockner's College. Welcome to Remote Monday for GCSE mathematics. We will be looking at rounding and estimating numbers. In this session I aim to recap rounding numbers to the nearest 10, 100, 1000 and 10,000. We will then move on to rounding to particular decimal places and significant figures. You will need pen and paper, but not a calculator. You can pause the video at any time to check your answers and to answer the questions, or rewind to watch again. This shows the attendance at two football matches, Arsenal against Chelsea and Liverpool against Spurs. In a moment you will need to pause the video and write the answers. First the attendance in words, then to the nearest 10, nearest 100, nearest 1000 and nearest 10,000. When you have written your answers, restart the video and we will go over the answers. Looking at the Arsenal match, the attendance in words is 59,912. Be careful of the spellings. To the nearest 10, we have to ask ourselves, is 59,912 nearest to 59,910, or would it round to 59,920? As we have only two units, it would be rounded down, and so we'd have the answer of 59,910. To the nearest 100, the answer is 59,900. To the nearest 1000, this is a bit tricky. We have to ask ourselves, is 59,912 nearest to 59,000 or 60,000? As we have 900, which is above the figure 5, we round up, so the answer is 60,000. And to the nearest 10,000, the answer is the same. Looking at the Liverpool match, the attendance in words is 44,330. I'm sorry that my picture is hiding the answers. To the nearest 10, that's going to be 44,330. There was no unit, so it doesn't change. To the nearest 100, the answer is 44,300. To the nearest 1000, the answer is 44,000. And to the nearest 10,000, it is 40,000. Stop the video and check your answers. We are now going to look at rounding to decimal places. We have 4.852 and we want to round that to one decimal place, often written 1dp. We count one number after the decimal point and draw an imaginary line and then look at the number after the line and ask ourselves, is this 5 or above? Here we have the number 5, so the answer is yes. And in that case, we round the number in front of the line up, so the answer is 4.9. Note that there is only one number after the decimal point, so we've written it to one decimal place. We're now going to look at 1.6949. We want that to two decimal places, 2dp. So we count two numbers after the decimal point and draw our line. We again ask ourselves, is the number after the line a 5 or more? And the answer here is no. So we therefore leave the number in front of the line the same, so the answer is 1.69. The next number, we have 5.2627, and we want the answer to 3 decimal places. So we count 3 numbers after the decimal point and draw our line. We look at the number after the line and ask ourselves, is this 5 or more? The answer is yes. So therefore we round the number in front of the line up, so the answer becomes 5.263. You can pause the video now to see if you can just look at it and try and make sure you're quite happy with this. Otherwise, we are going to ask you to use pen and paper to answer these questions. You will need to pause the video, and I want these numbers written to 1 decimal place, 2 decimal places and 3 decimal places. So stop the video and write the answers on paper, and then restart the video and we will give you the answers. Well done. Bye. So the answer to 63.4721, we wanted that to 1 decimal place. So we draw a line after the 4 and look at the number afterwards, which is a 7. That's 5 or more, and so we round the number in front of the line up, so the answer would be 63.5. These are the next few answers. The next one, 0.59999, and we want this to 2 decimal places. It's a bit tricky. We will draw the line after the first 9 and look at the number afterwards, which is also a 9. So we're going to round up. So we need to round the 9, which is in front of the line, up, and that becomes 10. So in fact, we get 0.60. And it's important here to make sure you write the 0 to show the 2 decimal places. We want 2 numbers after the decimal point. The next answers. I'm sorry that the next answers are hidden by my photo, so I'll give you the answers. So 149.9875 to 3 decimal places is 149.988. The 5 will make the 7 round up to an 8. 3.54029 to 3 decimal places will be 3.540. The 2 will not make the 0 change. And the last one, 0.59999, will round to 0.600. We want 3 numbers after the decimal point. Stop this video, mark your work, and make sure you have written down any corrections if you've got anything wrong. We are now going to look at significant figures. If you read an attendance at a football match was exactly 41,786, and a friend asked you about the attendance, you would probably say about 40,000. You wouldn't give it as an exact number. In this case, you are giving an approximate answer to 1 significant figure. The 1 significant figure here is 4, but it's important that you have the zeros to show the place value. When trying to round to significant figures, find the first non-zero digit in your number. This is your first significant figure, and every digit after this is significant even zeros. Count along the correct number of digits, same as the number of significant figures you are rounding to, and round normally. Check your answer makes sense. If you have rounded 32,745 to two significant figures and got an answer of 38, that isn't sensible. Your answer should be a similar size to your original number. So you don't count the zeros at the beginning, but any zeros in between or after are counted. We're now going to look at rounding to significant figures, and we're going to round to one significant figure first. The first number we have is 1472. So we count one number, one digit, and draw our line. So the line will come between after the 1. We look at the number after the line and ask ourselves, is it 5 or more? The answer is no. So it will not change the number in front of the line. So the 1 will stay the same. However, we must put zeros after this to give us our place value. So it's 1000. Looking at the next number, 26728. We want to round this to one significant figure. So we put our line after one digit. So we put the line after the 2. We look at the number after the line, which is a 6. We ask, is it 5 or bigger? And the answer is yes. So we therefore round the number in front of the line up, and so the 2 becomes 3, but we must have the zeros to give us our place value. So we need to put 4 zeros there to give us our 30,000. The next number, 0.0328. We want it to one significant figure. So we put our line after the first digit. We don't count the zeros in this case. We'd only count zeros if it was after or in between numbers. So the first number is a 3. We draw our line after the 3. We then ask, is the number after the line 5 or bigger? And the answer is no. So the number in front of the line does not change. So the answer is 0.03. I'm sorry, that's been hidden by my face. Rounding to two significant figures. We have the number 1472. So we count two numbers and draw our line. We look at the number after the line and ask ourselves, is this 5 or more? And the answer is yes. So we round the number in front of the line up, so that 4 becomes 5. So we get the answer of 15, but we need the 2 zeros to make our place value correct. So it's 1500. The next number, 26528. We want the answer to two significant figures, so we count two figures and draw our line. So the line will come after the 6 and before the 5. We look at the number after the line and ask ourselves, is it 5 or bigger? And the answer is yes. So we will round the number in front of the line up, so the 6 becomes 7. So we get 27, but we have to fill in the zeros, 3 zeros to place instead of the 5 to 8 to make our place value the same. So the answer is 27,000. The last example, we want our rounded to two significant figures, so we don't count the zeros. we start counting at the 3. So we go 3, 2, that's our 2 significant figures. Draw our line after the 2. Look at the number after the line and ask ourselves, is that 5 or bigger? And the answer is no. So the answer will be 0.032. Sorry, it's hidden. So the answer is 0.032. Pause this video to make sure that you're happy with this before going on to the next screen. We're now going to look at how to estimate answers to calculations. We're asked to estimate the answer to 6.32 times 9.5. When estimating, you first need to round every number in the question to one significant figure. If you have more than one significant figure, you won't get the marks in an exam. So we look at 6.32 and we round this to one significant figure, which is 6. 6.32 is between 6 and 7, but to one significant figure it's nearest to 6. We round 9.5 to one significant figure. Now 9.5 is between 9 and 10, but the 0.5, the 5 will make it round up, so the answer is 10. Note we only have one figure in the 6 and we only have one figure in the 10, the 1. The 0 is not counted, but it needs to be done there to show its place value. So 6.32 times 9.5 is approximately 6 times 10. 6 times 10 is 60. Easy maths. That curly equal sign means approximately equal to. So remember that whenever you're asked to estimate an answer, you round every number in the calculation to only have one significant figure, and then you do the maths. Sally bought 18 packets of crisps at 32p each. Estimate how much she spent. When estimating again, we first need to round every number in the question to one significant figure. We round 18 to one significant figure. 18 is between 10 and 20. So if we think about our imaginary line, we'd put the line after the 1 and look at the 8, which will round the 1 up because it's bigger than 5, and so we get 20. The 1 rounds up to 2, but we must have the 0 to keep our place value. Then we look at the number 32. We want 32 to only one significant figure. If we draw our line, we draw the line between 3 and 2. Look at the 2, which is below 5, so we will not change the 3. So it becomes 30. We must have the 0, though, to keep our place value. So we can now do the maths, the calculation. 18 times 32, approximately, rounded to one significant figure, is 20 times 30. 2 times 3 is 6, and we have the 2 zeros, so it's 600 pence, which is £6. In the next few slides, we are going to give you some questions that you need to estimate. You will need to round to one significant figure and then do the maths as involved. You can pause it at any time, work out the answer. You then need to choose the letter A, B, C or D, and then restart to see if your answer is correct. Answer to D here is 150, although it's hidden by my picture, I'm afraid, sorry. So you need to estimate the answer to this question. 54.6 times 2.91, rounding to one significant figure, then do the maths and choose your letter. To work out this answer, you'd have round 54.6 to 50 and 2.91 to 3. So it'll be 50 times 3, so the answer is 150. So the answer is 150 or D. Next one. Estimate the answer to this question. 2.1 times 9.7 times 3.7. Round each to one significant figure and write down the letter or number to your answer, A, B, C or D. Pause the video, work it out, then restart the video to see if your answer is correct. The answer is 80. 2.1 would round to 2, 9.7 would round to 10, 3.7 would round to 4. So you'd have 2 times 10, which is 20, times 4, which is 80. Estimate the answer to this question. Write down the letter or number, pause the video, choose your letter. And then restart the video. The answer is 600C. 34.87 to one significant figure is 30. 20.27 to one significant figure is 20. 30 times 20 is 600. How confident do you feel about this topic? Good? Okay. Or do you need some more practice? If you want to email your lecturer to have any queries or questions, do so on their email address or relate to them when you get back into class next week. You need to click on the link above this video that you will see on eBrock to complete the homework on My Maths. You will need to enter your username of 4 numbers and password of 3 letters that you will have been given by your lecturer. If this does not work, you may need to enter Brock, then Prime first before your own login. Make sure when you've done the homework that you click on Save at the end so that we will see your results. The link shown below won't work on the video, but you will see this link above the video on eBrock on Remote Monday. Good luck with everything. Hope everything goes okay with you. Bye.